Okay, hello. We are going to now talk about section 5.2, goal 2, which is another type of dividing, like long dividing, but it's completely looks completely different than what long dividing is, but you get the same result. So here's where we'll start. We'll start with the fact that you use synthetic division when dividing by a binomial. Typically it's in the form of x minus r. So you're dividing by something, a binomial, in the form of x minus r. So for example, we got 2x cubed minus 13x squared plus 26x minus 24. We're dividing by x minus 4. So we know that r is 4. Okay, so that's the form that we're dividing by a binomial. Now, I'm going to do long division quick, just so we can compare that to the synthetic division. So when I did long division, I won't talk it through too much here, but we just got done on the other video of long division. So we multiply by 2x squared, we get 2x cubed minus 8x squared. Subtract, we're adding 8. We get negative 5x squared plus 26x. We get negative 5x squared plus 20x. Subtract, and I get 6x minus 24 plus 6. I get 6x minus 24, which of course the remainder now is 0. Okay, so that was long dividing. My solution or quotient is 2x squared minus 5x plus 6. Now, using synthetic division, we're going to do basically the same thing, but using a different form, so a different process. The process that we're going to use with synthetic division is we need to be able to identify r. So r is 4. We are going to put r into this little box. So we've got 4 right here. Now it's a positive 4. Very important you understand that it's what you're subtracting here. Okay, so that is going to be 4. R goes there. We're going to draw another line right here. And next to the 4, outside of the box, we are going to place all of the coefficients of what we're dividing into. So 2, negative 13, 26, and negative 24. So I put a 2 here, negative 13 here, 26, and negative 24. Okay? So does everybody see where I'm getting these numbers from? All right, so hopefully that's clear enough for you. Now, here's the process. What's the first thing you're going to do is you're going to drop the 2 down here. The first number, you just drop it. The second number that goes here is you multiply this number times 4. So this is 8. Again, I take the number down here, 2, and I multiply it by 4. And I put it below the negative 13. Now, instead of subtracting like I did in long division, I'm actually adding this time. I'm going to add these, and I get negative 5. Okay? Now I take that number and multiply it times 4. I put it underneath the 26. And again, I'm going to add. So basically I'm multiplying, then adding, multiplying, and then adding. So I add, I get 6. Multiply again, I get 24. The last number I like to put a box around. Okay? And that ends up to be 0. Now, the reason I put a box around the last number is that is the remainder. if that is the remainder, then the next number to it is the x term. I'm sorry, I said that wrong. The next number next to it is the constant. So the constant, 6, plus the x term, which is negative 5x, plus the quadratic term, which is 2x squared. There is my quotient. And if you notice, it's the same quotient as over here. Now, if it had a remainder other than 0, we would add it on to the back. But since it doesn't, there's my quotient. Now, that's synthetic division. We're going to do a bunch of examples just so you can see it and you can follow it. I would like you to, at any time, pause the video, either rewind it and watch it again, or try it on your own and then start the video back up again so you can see if you're getting it right. I will try not to trip this time. Okay, so here is 4 examples. Example 4, A, B, C, and D. So let's go ahead and process this. Okay, using synthetic division, again, we're going to set it up. We're going to draw a little box here. We're going to draw a line here. We're going to identify what R is. R is negative 3 this time because it's always the opposite of that number. The coefficients of the polynomial we're dividing into is 2, 3, negative 4, and 15. And again, this last number is going to be, I like to put a box there for the remainder. Now we're going to process this, okay? So I'm going to drop the 2, multiply, negative 6, add, negative 3, multiply, we get 9, add, we get 5, multiply, we get negative 15, add, we get 0. So my solution or quotient is 2x squared minus 3x plus 5. There's my answer. Please do not leave your answer in this form. This is only the work. Your answer should always be rewritten as a polynomial. Okay, let's go over to B. We'll just keep doing the same process. Again, stop the video right now if you want to try this one and see if you can do it, and then I'm going to show it to you so you can see if you're right. Positive 2, 3, negative 8, 11, negative 14, remainder. 3, 6, add negative 2, negative 4, 7, 14, remainder of 0, and my quotient is 3x squared minus 2x plus 7. Now, I'm going to take this time right now to explain a couple things, or one thing for sure that you can kind of use to check your answer. I had this wrong up here, by the way. This was supposed to be a 3. Sorry about that if that messed you up. Okay. The reason I noticed that is because the point I'm trying to make here is I am dividing a cubic by a linear. If I take a cubic and divide by a linear, I end up with a quadratic when I'm done. So if I'm taking a cubic and dividing by a linear, my answer should be a quadratic. So that's something you can use to help you identify. So for example, in 4C, I have a 4th degree divided by a 1st degree. My answer should be a cubic or a 3rd degree when I'm done. So you got to use that as kind of helpful when you're trying to make sure you understand what your answer is going to be. Now, let's do the same thing here. Again, r is the opposite, so negative 2. This time I put a 4 here, but I am missing a cubic. Remember we talked about with long division, you have to account for all of the terms. Since I'm missing a cubic, I have to put in 0. Then 2, then negative 4, and then 12. Draw a line, put a box for your remainder, and go ahead and process. 4, negative 8, negative 8, 16, 18, negative 36, negative 40, 80, 92. There is my answer. So when I do my answer here, I know that my quotient or answer is cubic. So basically it's 4x cubed minus 8x squared plus 18x minus 40 plus 92 over a plus 2. When you have a remainder, you put it over what you're dividing by. So that is that answer. Okay, let's go with the last one here. Again, same exact process. Positive 2, I've got a 6. This time I have a cubic, which is negative 8, but I do not have a quadratic. So that's 0, 12, negative 14, line, remainder. Drop the 6, 12, 4, 8, 8, 16, 28, 56, and 42. So I end up with 6x cubed plus 4x squared plus 8x plus 28 plus 42 over x minus 2. There's my quotient. Now, we're going to go ahead and do a couple more, but this time they're just a little bit different. We're not exactly dividing by x minus r form, and I want to show you that. That's example 5. Okay, so example 5 has wait for it to dry a little bit here. Eight x to the 4th minus 4x squared plus x plus 4 divided by, this time, 2x plus 1. Okay, so this time it's not in x minus r form. So there is a little bit of a trick to that. Okay, so we know that we want to find r. Okay, so remember now, this basically is, I'm going to show this to you, but I usually don't show this work. But remember now, this is 8x to the 4th minus 4x squared plus x plus 4 divided by 2x plus 1. So if I need to or want to divide this by 2, I also have to divide this by 2 to get r. Now we have 4x to the 4th minus 2x squared plus 1/2 x plus 2 divided by x plus 1/2. So basically what I have here is I have r is equal to negative 1/2. So when I set up my problem, I have negative 1/2 here. Now I have 4, negative 2, 1/2, and 2. Now I'm missing the x cubed term, so that's 4, 0, negative 2, 1/2, and 2. Okay, so now I can use synthetic division. When I use synthetic division, of course, I'm going to have to deal with the half, which is not a big deal. I drop my 4, multiply, I get negative 2. I add, I get negative 2. Multiply, I get positive 1. Add, I get negative 1. Multiply, I get positive 1/2. That's 1. And then I end up with negative 1/2, which is 3/2. So my answer or quotient is 4x cubed minus 2x squared minus 1x plus 1, plus I end up with 3/2 over x plus 1/2. Now this is called a complex fraction. You're not supposed to have fractions within fractions. So to get it back, I don't have to multiply everything by 2, but I do need to change this by multiplying both top and bottom by 2. So my quotient is going to be 4x cubed minus 2x squared minus x plus 1, plus the top becomes 3, and the bottom goes back to 2x plus 1. Okay, so there's the trick on that one. Okay, we're going to do another one, but just take time and follow this again. If you need to re-watch this, do that. Okay, I can erase it since you have it on video. All right, we'll do one more, 5b. y to the 5th minus 2y to the 4th minus 16y squared plus 4, and we're going to divide this by 4y minus 1. Now, without doing all that extra work, what I'm going to basically do is I'm dividing both of these by 4. It gives me 2y to the 5th minus 1/2 y to the 4th minus 4y squared plus 1. Divided by y minus 1/4. Okay, so positive 1/4. I get 2, negative 1/2. I'm missing the cubic, so that's 0. I have negative 4 for my quadratic. I'm missing the y to the first term, so that's 0. And then I put in 1. Drop the 2, gives me 1/2. That's 0, 0, 0, 0, negative 4, negative 1, negative 1, negative 1/4, and 3/4. So my quotient is, this is going to be, remember I'm taking a 5th power dividing by a 1st power, so this should be my 4th power. So 2y to the 4th minus 4y, because I don't have to write down the zeros. This is cubed, this is squared, negative 4y minus 1, plus 3/4 over y minus 1/4. And again, I'm going to multiply top and bottom by 4 just on the fraction, which gives me plus 3 over 4y minus 1. So all of this and this. And there you have it. This is a long section, but again, it's usually done in class, and we talk about it the next day. Luckily for you, you get to rewatch this over and over until you understand it, I guess. Good luck, everybody.